Europe is at a crossroads. Energy demand is rising, fossil fuels are being phased out, and the continent's energy security is under pressure. While wind and solar have made remarkable gains, there's a growing need for reliable, scalable, and clean energy. Enter Newcleo, a bold European startup with a $3 billion plan to revive nuclear power using next-generation technology. Lead-cooled, fast reactors. On Innovation Corner with Dan, we're going inside this ambitious project to understand how it works, why it matters, and why it could be Europe's nuclear comeback story. For decades, Europe led the world in nuclear innovation, but political resistance, public opposition, and economic hurdles slowed progress. Many traditional nuclear plants were retired, leaving gaps in energy supply and increasing reliance on fossil fuels. Today, with climate change pressure mounting, there's renewed interest in nuclear energy. But this time with a modern twist. Newcleo is at the forefront of this revival. Their mission is simple, yet daring. Build small, efficient, and safe nuclear reactors capable of powering entire regions while addressing the long-standing challenges of waste, cost, and safety. Their chosen technology, lead-cooled fast reactors, promises to tackle these issues head-on, making them a company to watch in 2025 and beyond. The problem Newcleo aims to solve. Traditional nuclear reactors rely on water as a coolant and uranium fuel, producing energy over decades but creating high-level radioactive waste and complex safety requirements. Many reactors are large and expensive, costing billions and taking a decade or more to construct. Europe faces three key problems in this context. Energy security, with fossil fuel dependency decreasing and renewable energy still intermittent. Reliable baseload power is in demand. Climate goals. Nations are under pressure to reduce carbon emissions rapidly, requiring clean energy sources that can complement wind and solar. Public concerns and costs, safety fears, and financial risks have made traditional nuclear projects politically and economically challenging. Newcleo's approach directly addresses these challenges, offering a smaller, safer, and faster-to-deploy alternative. Lead-cooled fast reactors. How they work. At the heart of Newcleo's technology is the lead-cooled fast reactor. Unlike conventional reactors that use water as a coolant, LFRs use molten lead or lead-bismuth alloy. Lead has several advantages. It has a high boiling point, meaning it can operate at very high temperatures without pressurization, improving efficiency and safety. It is chemically inert with water and air, reducing the risk of violent reactions seen in some other reactor designs. It allows for a fast neutron spectrum, which can make fuel use more efficient and reduce long-lived radioactive waste. The fast neutron spectrum is particularly important. Fast neutrons can trigger fission in isotopes that would normally be inert in conventional reactors. This means Newcleo's reactors could use a wider variety of fuel, including spent nuclear fuel from other plants, reducing waste and improving sustainability. The $3 billion plan Newcleo has secured $3 billion in funding to bring their vision to life, making it one of Europe's most ambitious nuclear ventures. The plan is not just to build a single plant, but to establish a network of modular reactors that can be deployed across Europe. Modularity is key. Instead of constructing enormous plants over a decade, Newcleo's reactors are smaller and standardized. Components can be prefabricated, reducing construction time and costs while ensuring high quality and safety standards. The first plants will demonstrate the technology at scale, providing both energy and a proof of concept that could unlock further deployment across the continent. Investors, governments, and energy companies are watching closely, as success here could reshape Europe's energy landscape. Safety advantages. Safety has been a major barrier for nuclear energy adoption. Lead-cooled fast reactors offer inherent safety benefits. Passive cooling. In emergencies, natural convection allows the reactor to cool without human intervention or power, reducing the risk of meltdown. High thermal capacity. Lead can absorb a significant amount of heat, giving operators more time to respond to unexpected events. Reduced pressure risk. Unlike water-cooled reactors, there's no high-pressure system that could fail catastrophically. Fuel efficiency. Using fast neutrons, Newcleo's reactors can extract more energy from the same fuel, producing less long-lived waste. These features make LFRs attractive not just from an engineering perspective, but also for public acceptance. which is crucial for any nuclear project in Europe. Environmental and waste impact. One of the most compelling aspects of Newcleo's design is its approach to waste. Traditional reactors produce high-level radioactive waste that remains dangerous for thousands of years. Lid-cooled fast reactors, however, can use spent fuel from other plants, transforming it into usable energy while reducing the half-life of remaining isotopes. This has enormous environmental implications. By recycling nuclear material, Newcleo reduces the volume and toxicity of waste, making long-term storage easier and safer. It also means the reactors are more sustainable over the long term, contributing to a truly circular energy economy. Economic implications. Europe's energy market is expensive and competitive. Large nuclear projects have historically been plagued by delays and cost overruns. Newcleo's modular approach aims to overcome these challenges. By prefabricating reactor modules in factories, construction can be faster and more predictable. Standardized designs mean maintenance and training costs are lower. And by using advanced fuels efficiently, operating costs are reduced over the plant's lifetime. The $3 billion investment isn't just for building reactors, it's an investment in the future of European energy, creating a model that could be replicated across countries with growing demand for clean, reliable power. Challenges ahead. Despite the promise, challenges remain. Lead-cooled fast reactors are complex, and while the technology has been studied for decades, no commercial deployment exists at scale in Europe. Handling molten lead safely requires advanced engineering and operational expertise. Regulatory approval is another major hurdle. European nuclear authorities are cautious, requiring rigorous testing, simulation, and validation before granting licenses. Public perception is also a challenge, as nuclear energy remains controversial in several countries. Finally, integrating these reactors into modern energy grids requires planning. While the reactors are flexible, they must work alongside renewable energy sources, manage load fluctuations, and meet regulatory and safety standards simultaneously. Global significance. Newcleo's project is not just a European story. If successful, it could inspire a global renaissance in nuclear energy. Lead-cooled fast reactors could provide a blueprint for countries struggling with energy security, climate goals, or aging nuclear infrastructure. For developing nations, modular reactors could provide scalable power without requiring massive investments or long construction timelines. For the world as a whole, more efficient reactors with lower waste production could make nuclear energy a cornerstone of climate action. We see Newcleo's approach as a potential turning point, not just for Europe, but for the future of nuclear power worldwide. The role of innovation and technology. Newcleo's success depends on combining decades of nuclear physics knowledge with modern engineering, AI-driven monitoring systems, and advanced materials. Their reactors are designed to be not just functional, but smart, with sensors and controls that optimize performance, detect anomalies early, and reduce human error. This integration of technology is key. Unlike the nuclear plants of the past, which relied heavily on manual operations and rigid designs, Newcleo's reactors are adaptive, intelligent, and future-ready, aligning with the evolving energy landscape. Why Europe is betting on nuclear? Again, Europe's renewed interest in nuclear power comes from necessity. Climate targets are aggressive. Renewable energy alone cannot guarantee baseload power, and geopolitical tensions have exposed vulnerabilities in energy supply chains. Lead-cooled fast reactors offer a way to meet these challenges safely, efficiently, and sustainably. Newcleo is positioning itself as the bridge between Europe's nuclear past and a clean energy future. If successful, it could reverse decades of stagnation, rebuild public confidence in nuclear energy, and accelerate Europe's transition away from fossil fuels. Europe's $3 billion nuclear comeback is more than a headline. It's a vision for the future. With lead-cooled fast reactors, Newcleo is tackling safety, efficiency, and waste challenges simultaneously. They're showing the world that nuclear energy can be modular, scalable, and environmentally responsible. We celebrate the innovators who dare to dream big, challenge conventions, and create solutions that could reshape entire industries. Newcleo isn't just building reactors, they're building a path toward a cleaner, safer, and more resilient energy future. The European nuclear renaissance is underway, and with projects like this, the energy landscape of 2030 could look very different from today.